Hi, everyone. This is George Rivera. I'm a sales engineer and thermographer over at T Equipment. Welcome, everybody. I want to give a minute or so for everyone to finish logging in. And I'll introduce Justin Sheard in a moment, and just want to give it a minute here. I'm going to mute my line for a minute. All right, well, let's get started. Again, my name is George Rivera. I'm one of the sales guys over at T Equipment, and I want to introduce Justin Sheard. He's a senior engineer and industrial imaging specialist with Fluke. He's a veteran of over 20 years of experience with various instrumentation, and he's had a number of different roles at Fluke over the last years, especially in the thermal imager area. He has over 10 patents, and so we're very lucky to have him here to do this presentation on the ii910, the latest product from Fluke. And Justin, as far as educational background, he has a master's of mechanical engineering from the University of Minnesota and a Bachelor of Science in Physics from Bethel University. I'm not sure if I pronounced that right, Justin. Anyway, Justin,
fine.
Let me let you
Yep.
take over. I did want to, while we were waiting, just for anyone last minute to log in, I just want a quick slide about our company. T Equipment's been in business for over 19 years. I'm one of several certified thermographers here, and I'm a mechanical engineer as well. And we service our customers not only from our East Coast office and warehouse out here, but there's also one on the West Coast. And you know, we carry not only Fluke, but a number of other instrumentation brands and a number of related fields, some of them, or most of them, non-competing with Fluke. And as this little slogan says here, real people here to help you. You know, please feel free to call us. I know everyone's always anxious to use email or chat, but we're happy to talk to you. There's real people here to help you. And also, just real quick, it's St. Patrick's Day for anyone that celebrates. Happy St. Patrick's Day. All right, Justin, let me let you take over, and while you get started, I'll transfer control of the presentation to you.
All right.
All right, so you should be seeing, yep, I see your slide deck.
All right.
Yep,
How's
you're all
it look?
set. Yep,
Okay.
you're all set. I'll mute my line. Just a housekeeping thing. Anyone have any questions? I'll be monitoring the chat. Please submit your questions there. We'll try to address them all at the end of the presentation, and everyone gets a recorded copy that will be emailed to you tomorrow. All right, Justin, take over. Thanks.
All right. Thanks. Happy St. Patrick's Day. That's a good reminder. Today we're going to talk about the Fluke ii910 acoustic imager. And well, first of all, before talking about the ii910, I want to make sure that everyone understands its predecessor, the ii900, which was the first handheld industrial acoustic imager of its kind, designed specifically as a tool to locate leaks. And so even the term acoustic sound imaging, what the heck does that mean? Well, it's really a technique that is creating an image of the scene based on the sounds in the scene. So similarly to thermal imaging in some ways, it's receiving a signal in a certain field of view and turning that into a picture. In this case, we overlay it onto a visible image so it can be of value and you get the context. So in some ways, it kind of looks like a thermal image too because of the color scheme that we have. And the ii910, which launched almost 2 years ago now, changed the game in leak detection. It now, with literally no training, a person could locate and take a picture of leaks where it would take much more time and a lot of effort to do in the past. So this slide is kind of comparing old ultrasonic tools versus the ii900, where we tested it quite a bit, where we would kind of just hand it to somebody, let them scan the area, and they started finding leaks, and really were excited that it's so easy to use. And the 900 would meet needs across many different industries. So it's not just compressed air leaks, but it's other gases and other issues that can detect, really. So it kind of hits a lot of different areas in industry. And now for the ii910. Well, it's designed really to be a more powerful, kind of think more sensitive leak detector. So that'll open up some other application spaces. That's what we're saying the new is, or the expansion. And the new is the detection of partial discharges. And I'll get into why that's important, but in short, the ii910 kind of offers some of those same values I talked about with the 900, which changed the game, of incredibly easy to use, as an issue detector, the fact that it gives you a picture, very little training. So it's kind of the same. It's really just an add-on to the highly successful 900. I want to start by showing you a video, and we can talk through. It kind of gives a nice overview, I think, what the 910 does. All right, so it's this handheld. Both of those look really the same, the 900 and the 910. Very simple interface. It's the touch screen, only a couple buttons, power button and capture. And then it's going to give you indications on the screen. And in both cases, an opportunity to create a report that can be shared. There are indications of the distance, which can be helpful and if utilized in the calculation, and then an online report generator that it shows here. So again, ease of use, kind of trying to push that, and I think we really hit that mark. As far as the difference here now between the 900 and 910, and with most competitors, there's a wider frequency range, and we'll go into that a little bit more. It really gives you a better chance of detecting some of those leaks and some of the partial discharge too. And although not the highest value product here, some of these reports can be useful for the right person. Gives you some more information that you might need. All right, that's good for that. Any questions at this point? Are we getting anything on the chat that we should address?
Does it work for locating nitrogen leaks under 5 psi? I think we had talked about this before.
Yeah.
We're going to cover
not
some of these.
Yeah.
I don't know if you want to do that now, but so far
I can answer that right now. But yeah, that's a great question. It's really depends on flow rate mostly. So pressure can be an indication of that, but you can't tell just by saying it's 5 psi whether it would be able to detect that nitrogen leak. There's a lot of other factors, but yeah, the higher the pressure generally causes more flow, which creates more of that vibration coming out of the leak. But there's many different types of leaks that make more or less sound even with the same flow rate. So kind of it depends. All right, so the imager itself, again, really looks the same as the 900 except for this small white circle on the front of the imaging head, and has a lot of the same features. High battery life, we talked about the wide frequency range, and video recording as well. So you can really just touch the screen and it gives you these options of either capturing an image, capturing a video, or capturing one of each of these two specialty modes called the leak queue or the PDQ, which further analyze the leaks or the partial discharge. I've kind of talked to these and the differences, but really it's the frequency range that's different, which gives you a larger distance capability of detection. So if you have the same leak, you can detect it at a further distance. And the leak queue and PDQ. So the older model doesn't have PDQ, but the newer model has both. Now looking into PD a little bit more, when considering partial discharge, we're talking about high voltage, so at least greater than 5 kV. And from a grid network perspective, we see that the main application is before the consumption. And when you talk about electrical generation, transmission, and distribution, it's usually in the generation or somewhere in transmission and distribution. And so it can be the step up or step down voltage locations where it's common to be able to, well, to have a need to detect partial discharge because they are causing issues. So partial discharge, what is it? Well, from a definition standpoint, it's an electrical discharge that doesn't completely bridge the space between two electrodes or conductors. And this would be in medium and high voltage electrical equipment. And in practice, what it is it's something that damages equipment, or at least a lot of the types of partial discharge are damaging to high voltage equipment. And over time, the repeated energy that is produced there will degrade the equipment. It's actually the insulation that it's degrading in there. And it has effects through that degradation of mechanical, it'll be thermal or chemical breakdown, depending on the type of partial discharge and the equipment. We can talk about the different types of partial discharge. I've broken it down into these 4. Sometimes there are different words used, but it's really some of the same things. Corona, and this is a type of discharge. Often by itself, it's not a safety problem or a degradation of the equipment. It's more of noise pollution. It does cause some reduction in the it hurts the power generation there, but it's usually not something that people worry about. Surface discharge, on the other hand, is also called surface tracking, and it definitely is one of the larger issues. You can see it visually sometimes, but it comes from contamination on the insulator surface. So once there's a way for that energy to go across, it can damage there. And I talked about how partial discharge is really this repeated charge across electrodes. Sometimes that's phase to phase, and sometimes that's to ground. Usually surface discharge is tracking to grounded metal. The other one I'll talk about is void or internal discharge. And this is another one that definitely damages equipment over time. And it's in this insulation material. So it can be insulation that's solid, or it can be gas or liquid insulation, but it's pretty common to find this in cables, in bushings, or anywhere that there's a junction between components that have insulation. And we identified two clear segments of needs. So the industry knows that there's partial discharge and it's causing these issues. Well, what do they need? They need to detect and locate. So this is a basic need specifically demanded by distribution utilities and by industrial high voltage users. And so it's what's the best way to easily detect that there is partial discharge there, but then also locate exactly where it's coming from so that something can be done about it. The one on the right is then this analysis and diagnosis, which is also a need usually for a slightly different customer, different persona, but they want to know what type of partial discharge it is, or other aspects like the pulse number or the PRPD plot. So we have some of that built into the ii910, but I would say our detection and location is where we shine the most. Another view of the needs is by persona breakdown. And once again, we're looking at detect and locate for power generation and distribution. There's also the OEM side, which is number 3 there. And I'll show some examples of that later. But from a value prop, we're talking increased uptime, being able to notice an issue and fix it before it becomes catastrophic. This can affect product and equipment quality, especially for OEMs where they need to design that product that it doesn't produce partial discharge, or also service items in the field that come back and ensure that it's been fixed correctly. And cost and energy savings is kind of a given there, as well as safety. Partial discharge, safety is usually the largest value for customers in trying to detect partial discharge, because left unchecked, it can become a catastrophic arc, which could destroy equipment and kill people. So we definitely don't want that. All right, let's look at now at workflow examples. Unless there are other questions on the chat, I'll stop here for a second.
Well, the ones that we had talked about, I'm not sure if you want to answer some of them now. Again, here's one for gas leaks. How much pressure do you need on the system when you are testing? I think you can.
Yeah, I kind of touched on that. There's no set answer to that really, because of how sound is changed by the application, including the type.
Yep. Here's another good one. So let's say you're looking at a refrigeration system while it's running. So the compressor is running and the condenser fan is running. Will that interfere with the leak measurement?
Generally, no, from a sound standpoint. That's a great question, because, but it really filters out all that background noise. In 95% of the cases, it's not an issue at all. And it's pretty surprising, really. You'll be in a factory or it'll be super loud, and the algorithms behind kind of turning it into that picture remove the background noise, and it's great. You don't have to turn equipment off or anything.
Okay, that's it for now.
All right, okay. So now I want to talk about the workflow, because what is it that happens in detecting and locating it, and really why did our customers say they wanted a tool like the ii910? Well, from a use standpoint, faster and easier. So on these routes, can they do their routes by the preventive maintenance teams faster? And then, of course, detecting there's a potential issue, locating that partial discharge, and then documenting it. So now, instead of having to tag something physically or write notes with a pen or on a piece of paper or somewhere else, you can document that picture or video or the report and send that to whoever needs to know that. Also, kind of planning the repairs, it's easier to escalate with a picture, video, report, and then plan for the resolution there. And then finally, it's kind of not always thought about that verification is important, but it's also fast verification that something's fixed, instead of having to go back and do the other types of tests by hand or really digging into it deeper to see if it's truly fixed. So that's a great benefit that is kind of overlooked often. Okay. And now this is the other type. So this is an example of an OEM high voltage rotating equipment. And it can be a good tool, the ii910, for a part of a quality assessment in manufacturing, because you can see exactly where is that potential partial discharge coming from. In the past, or with previous methods, the companies would have to secure the area, excite the equipment with high voltage, and then oftentimes use a probe-like tool to detect. And those would generally not tell you the exact location, just what type was present. Here's an example of that, kind of instead of using a probe, you can scan and it gives you an indication of where to look closer. So safer, being able to scan from a distance, the pinpointing and ease of use. And then what I have left is a couple other examples, kind of comparing what the acoustic imager gives you on the left versus a competitive type of product. So definitely different, and you can choose to decide whether one is easier or the other, but certainly it's different and gives you a different type of view that we think is maybe easier for somebody to identify the location. What you need is line of sound, is what I'm calling it. So you don't have to have direct line of sight. That partial discharge might be on the back side of that insulator, but the sound is emanating and coming toward us. So there's another kind of slight advantage there, benefit really. Another common place to find partial discharge would be something like this on a transformer station and on the bus bars. So this picture on the right shows that you could visually see that there might be an issue there if you look closely, because there's some of that tracking on the outside. But the view of the acoustic imager there also quickly and precisely locates where that's coming from. Another view and a different type of tool is being compared on the left, but you can see that it gives you that indication of where, if we were to take that information and put it into the PDQ tool, it would tell you whether it thought that was internal tracking or some other type. All right, that's it. Any other questions?
Hang on, let me get there. I guess one is going to be the you could just go over again the ii900 versus the ii910.
Sure.
Difference between them.
This might be the best slide. It's okay. The 910 is really building on the 900. So everything the 900 has, the 910 has also, but from a sensitivity or leak detection, it's better. So anything the 900 can detect, the 910 can also, but smaller leaks or leaks at a larger distance could be detected by the 910.
Okay.
Additionally, the 910 is specifically designed for partial discharge, so it looks at a wider frequency range, which also helps for leaks, by the way, but the partial discharge sometimes is outside of that range of the lower frequency range, so you want to have a better chance of detecting that. Also, we added algorithms to better analyze the partial discharge. So the 900 might detect some of the partial discharge cases that the 910 does, but it's not designed for it.
Can the image be exported to a PC or a printer?
Absolutely. Yeah, so the method right now is to use USB-C and download those directly to your PC. So just a cable connection. Don't need Wi-Fi or anything else there. And then those files can be then put into an online report generator or a local version through our Fluke Connect desktop.
I'm not sure how relevant this is, but there's a question about the video capture, what the frames per second are. I'm not sure.
Yeah, it's a
that
little
would
bit
be
less
important.
than 30 frames per second. I think it's in the 25, but it does capture video at a reasonable rate. Yep.
Okay. Let's see. Anyone else? I guess while I'm looking for other ones.
Well, and I have something that maybe comes up as a question too. Sometimes there's a question about the frequency range, and well, most of the time you don't need to adjust what the camera is detecting, what frequency range. It does it automatically. So there's not a lot you really need to do, but in certain cases, you may want to look at a lower frequency range or a higher, or change the band that is looked, and you can do that directly on the camera. The right side, you can kind of see it in this picture. You can see it better on this picture, but the scale on the far right is the frequency range, and you can adjust that. So there's a lot of smarts in here and customization you can do, but the nice thing is you really don't have to.
And while you have that screen up, this question is relevant. What is the technical basis for detection? I mean, what is the sensor being used?
Oh yeah, great question. I didn't really even say that. I mean, it's a number of digital microphones. So this one we have arranged in 64, kind of a flower pattern of sorts, and it because of the distance and the width apart and the way that it's detecting sound over time, it listens to that sound and then quickly determines where the sound is coming from, what direction, and filters it and all that. So there's a lot of calculation going on, but the detection technique is microphones that are able to sense primarily in that ultrasonic frequency range.
All right, here's a more specific question. I know we're trying to keep things general, but maybe of use to other folks. We currently have a capacitive sensors for partial discharge detection on our generators. To use the ii910, would the method have to have a line of sound instead of line of sight access to the windings
Yeah.
during a unit shutdown with the windings excited by a high voltage source?
Yeah, that's a good question. I think I'd have to look at that exactly, but you do need line of sound in some ways. Sometimes that can be a closed cabinet that just has enough holes in it for that sound to come out to know that, hey, we need to investigate that. So it kind of depends on what the equipment looks like and whether you're having those discharge events happening at that moment.
Okay, so that kind of covers the questions. I just did want to take over control and show this last slide that I have. Let me do that. And then, oh, okay, so Justin, you could tell me, you could see this last slide, questions.
Yep.
Okay, so certainly I wanted to give everyone my contact information and our office here. I'm available. You can call the office, ask for me, or send an email. We are sending an email tomorrow with a copy of the presentation, but we also have, if you go to our website, tequipment.net, and you type in IWH course in the search box or follow the URL here, we post all previous webinars that we've done. As you scroll down the page, you'll see the YouTube recordings, and then you'll also see the PDF slide decks there. There's past ones that we've done with Fluke, as well as other manufacturers, all kinds of different topics. There may be something there that might be of interest to you. You're welcome to use that as a resource. And again, Justin, thank you so much for taking the time. I know, I'm sure you guys have more questions that we have not addressed. Please reach out to me, and if necessary, I'll get a hold of Justin or whoever I need to at the factory to address your questions. And again, Justin, thanks.
Yes. You're welcome. Thanks.
All right. Goodbye, everybody.